Hello students, welcome to Sharmila's Math. In this video, we are going to interpolate values with equal intervals. In my previous two videos, I have explained how to use Lagrange interpolation formula and Lagrange inverse interpolation formula for unequal intervals. Lagrange interpolation formula can be used for equal and unequal intervals. That already I have given in that video. Okay, but particularly, we are using Lagrange interpolation formula only for unequal intervals. If the intervals are of equal length, we have to use Newton's Gregory interpolation formula, or in short we can call that as Newton's interpolation formula. In that we have two formulae. One is Newton's forward interpolation formula and the other one is Newton's backward interpolation formula. I will explain you when to use Newton's forward and when to use Newton's backward and how to use Newton's forward and backward in this video in detail. This is the formula. The first one is for Newton's forward interpolation formula. Y of x is equal to these two things, just it is a symbol, don't take that. Y of x is equal to, this is the formula, y naught plus u by 1 factorial del y naught plus u into u minus 1 by 2 factorial del squared y naught plus u into u minus 1 u minus 2 by 3 factorial del cube y naught plus etc. What should be the next term? U into u minus 1, u minus 2, then u minus 3 by 4 factorial into del power 4 y naught. Like that we have to extend the terms where u is equal to x minus x naught by h. And in the backward interpolation formula, y of x is equal to yn plus v by 1 factorial. This is reverse delta. Delta yn plus v into v plus 1 by 2 factorial del squared yn. This is actually, this is del and this is reverse del. But when we say, we can call this as del. Del squared yn plus v into v plus 1 v plus 2 by 3 factorial del cube yn plus etc. Here we are subtracting the values and here we are adding the values where v is equal to x minus xn by h. When to apply Newton's forward? I'll show you in this example. See, this is the question what I am going to explain in this video. We are going to find the value of y at x is equal to 21 and x equal to 28 from the following data. 20, 23, 26, 29 are the values given for x and the corresponding y values are given in the problem. We have to find two values for y. When x is equal to 21, what is y? And when x is equal to 28, what is y? Okay. So we have two formulae. When to apply Newton's forward? See the question, what is the x value given? X is 21. If the x value is close to the beginning set of values. What do you mean by beginning set of values? Totally we have values from 20 to 21. Okay. Before going into the problem, we have to confirm whether x values are of equal interval, because Newton's forward or backward is applicable only for of equal interval. Lagrange is applied for unequal particularly, but for equal also we can use that formula. But Newton's is applicable only for of equal length. Okay, so 20 plus 3 has been added, so 23, then 3 has been added, 26, then 3 has been added, 29. So it is of equal length. Okay, so it is equal length. So we have to apply Newton's forward or backward. Depending upon the question asked, we have to select whether we have to apply forward or backward. But in this question, we are going to use both the formulae. 21 is close to these two values. From 20 to 29, what is the mid value? 26 to 29. I'm sorry, it is not 26 to 29, it is 23 to 26. What is the mid value we have? It is 24.5. That is the midpoint, right? So, if you take the left side values from 20 to 24.5, if you are having a x value means we have to use forward. From 24 to 29, if we have any value, we have to use backward. If exactly 24.5 means, if x is 24.5, both the formula we can use either forward or backward. But if x value lies to the left of 24.5, from 22, the left of 24.5 means we have to use forward. And in the right side, up to 29 means we have to use backward. So beginning set of values close means we have to use forward. End set of values, if it is close means we have to use backward. Is it clear? Okay. Now come to this problem. 21 lies in this limit, right? So for this we have to use backward, and 29 lies here. So we have to apply backward. And this is the formula for backward, forward and backward. Forward formula is based on the beginning set of values. So it depends upon x naught, the first value of x. And backward is based on the n set of values. So in this formula, we are using xn. So for example, no, the x values given are x0, x1, x2 like that. And the corresponding y values are y0 and y1, y2, etc. So if you are using forward means, first we have to find the term u. U is equal to x minus x0, the beginning value, by h. H is the common difference. What is the common difference? We have added 3 units with all the values. No, 20 plus 3, 23, 23 plus 3, 26, 26 plus 9, sorry, 3, 29. So h is that, x minus x0. What is x? The value given in the problem, 21. So 21 is our x. And what is x0? The first value. This is our x0. This is x0. This is x1, x2 and x3. This is our xn. Okay. And the corresponding values y0, y1, y2 and y3. So 21 minus, what is the first value? 20. 20 by h is 3. First you have to find u and we have to use that in the formula. Similarly, when we go with the backward, v is equal to x minus xn by h. X is, in the second one they have given x as 28. So 28 minus xn for this problem is 29. 28 minus 29 by h is 3. Okay. And for both the formula, the difference table is same. First, we have to find the difference table. Then we have to apply the formula. We will see one by one. This is the format of the difference table. In columns, we have to take x value given and y values given. X and y values given in the problem. The next one is del y, del squared y, del cube y. This is no, count the number of values 1, 2, 3, 4. If you have 4 terms, up to the third order we have to take here. The difference is up to the third order. This is the first order difference. This is the second order difference. And this is the third order difference. Del y, del squared y, del cube y. If we have 5 values means up to the fourth order difference we have to take. Okay. Is it clear? Okay, the respective data given I have taken in these 2 columns. Now we are going to fill these 3 columns. First I am going to find the first order difference. First order difference, del y is nothing but del y is equal to, what is this? This is x0, x1, x2 and x3. This is y0, y1, y2 and y3. Del y is equal to, and that is here. Del y0 is equal to y1 minus y0. That is the formula. That is the second value minus first value. For example, if you go with del y1 is equal to y2 minus y1. This value minus this value. The corresponding value minus the previous value. Is it clear? So first I am going to find del y0. Del y0 is equal to 0.3907 minus 0.3420. What is the difference? This is the difference, 0.0487. So we have to write this in between these 2 values. So del y0 has to be written at the middle of these 2 values. What is the next thing? Del y1. Del y1 is equal to 0.4384 minus 0.3907, which is equal to 0.0477. That I have to write at the mid of these two values, 0.0477. So in between we have to write this. The next one is del y2, which is equal to 0.4848 minus 0.4384. What is the answer for this? 0.0464, which I have to write at the mid. So the first order difference values we have calculated: 0.0487, 0.0477, 0.0464. So we have completed the first column. Moving on to the next one, that is the second order difference. The same method, second value minus first value, that is del squared y naught. Del squared y naught is equal to del y1 minus del y naught. This is the formula. No need to write all these things in your table. Just keep in memory the second value minus the current value. That is, if you consider this as the current value, means current value minus the previous value. And you have to write the what is the difference we are calculating? No, that has to be written at the middle of these two values. So 0.0477 minus 0.0487. What is the difference? See, this is the greatest quantity and this is the smallest quantity. So the difference will be in negative sign. Minus 0.0010. Concentrate on signs because we may get negative values. So concentrate on this sign. This one. 0.0464 minus 0.0477. This is also, this is smallest and this is greatest. Again, we are going to get a negative quantity, minus 0.0013. This is my second order difference. Moving on to the third order difference, the formula is del cube y naught is equal to del squared y1 minus del squared y naught. Just a second value minus this value. Okay, so we will calculate minus 0.0013 minus, again this value is in negative sign, no, minus 0.0010. So minus into minus plus. So minus 0.0013 plus 0.0010. This is the greatest value having negative sign and this is the least value having positive sign. So we have to find the difference and give the sign of the greatest value. So it is negative of 0.0003. So the last order difference, third order difference value is minus 0.0003. So that's how we got the difference table. For applying both Newton's forward and backward, the difference table is same. So first you have to write x, then y, then del y, del squared y, del cube y. We have to keep on moving up. See the number of values. So if it is 4 means up to third order, 4 minus 1. If it is 5 means 5 minus 1, 4. Up to fourth order, we have to fill in this table. And this value minus this value. Subtract this minus this and take at the middle. This minus this, take at the middle. This minus this, take at the middle. Similarly, for the second order, this value minus this value, right at the middle. This minus this, middle. And this minus this, right at the middle. You have to concentrate on the signs because we are getting negative value. Here what we got, no, negative of negative, so it is positive. So finally we are getting a negative value. Come to the formula. We have to use Newton's forward for if x value is close to the beginning set of values. So first, for the first one, x value 21, we have to apply Newton's forward, and for 28 we have to use Newton's backward. Okay, so what is my u? U is equal to x minus x naught by h. First we are going to apply Newton's forward. U is equal to x minus x naught by h. Here x is 21 minus x naught. What is x naught? 20 by h is 3. So 1 by 3 we have to simplify and we have to write up to 4 decimals. So 1 by 3 is 0.33333. It will move on, but I am taking only 4 decimals, 0.3333. Come to the formula. What is y naught? Y naught is this one, 0.3420. What is del y naught? Del y naught means this one. This is my del y naught. And del squared. This is my del squared y naught. And this is my del cube y naught. So when we apply Newton's forward, we are using the beginning set of values. So better you encircle like this the beginning set of values when we use Newton's forward. This is the formula. Y of x is equal to y naught plus u by 1 factorial del y naught plus u into u minus 1 by 2 factorial del squared y naught plus u into u minus 1 u minus 2 by 3 factorial del cube y naught. Since we have up to the third order, I have extended the formula up to the third order. First we have to calculate what is u. What is the formula for u? U is equal to x minus x naught by h. I'm sorry, this is up by h. Already we have calculated. Again I am doing 21 minus 20 by 3, which is equal to 1 by 3, which we took as 0.3333. Up to 4 decimals I have taken. Now we are going to substitute the values one by one. What is my y naught? 0.3420. 0.3420 plus what is my u? I got 0.3333 by 1 factorial into what is my del y naught? 0.0487. 0.0487 plus what is my u? This one, 0.3333 into u minus 1. 0.3333 minus 1 by 2 factorial. What is my del squared? It is minus 0.0010. Minus 0.0010 plus u into u minus 1, u minus 2. So 0.3333, 0.3333 minus 1, 0.3333 minus 2 by 3 factorial into what is my del cube? It is minus 0.0003. Minus 0.0003. Is it clear how we have applied the formula? Now we have to simplify the values. The first one as it is we can take 0.3420 plus this one is 0.3333. 1 factorial is 1 into 0.0487 and the second value is 0.3333 into the minus 1 we have to take no. When we subtract this, we are getting what we are getting? 1 in negative sign. 1 is the greatest value. So after subtracting, this will be of negative sign 0. So what we have to find? 0.3333 minus 1. It is minus 0.6667 divided by 2 factorial. We have no. What is 2 factorial? 1 into 2, which is 2. So 2 into minus 0.0010, this value. Right? Now come to the last term, this term, 0.3333 into this one already we have subtracted. We got this answer with the negative sign. So minus 0.6667 into minus 2 we have to take no. So 0.3333 minus 2. So what is the answer? Minus 1.6667. Minus 1.6667 by what factorial we have? 3 factorial. 3 factorial is equal to 1 into 2 into 3, which is on the whole it is 6. So what is 3 factorial? I repeat, 3 factorial is equal to 1 into 2 into 3, which is equal to 6. Is these values visible? I'll repeat, when we take this one, no, u minus 1. U minus 1 is in negative sign and this value also negative sign. 2 factorial is 2. And come to the third, this. When we subtract, we get the same thing in negative sign. And when we subtract, this is minus 1.6667 by 3 factorial is 6. And the respective y value is minus 0.0003. So after this, we have to simplify the values. While simplification, see the sign and find. Here minus into minus, this term will be in positive sign. Here totally how many minus we have? 1, 2, 3. So this is in negative sign. So correspondingly we have to simplify and get the answer. Final answer I will give. Final answer means y of x. What is x here? Y of 21. X value is 21. So y of 21 you have to get 0.3583. This is the approximate answer for this question when we apply Newton's forward. What's the next one they asked? We have to find what is given x28 and we have to find what is y. Since 28 is close to the n set of values, we have to use Newton's backward interpolation formula. In backward, first we have to find what is v. What is the formula for v? V is equal to x. X is 28 minus the n set of values. Xn is the last value, 29. So 28 minus 29 by the same h, which is equal to 3. Which is equal to, what is the simplification we are getting? Minus 1 by 3. Either you can convert this to a decimal point or as it is we can take. Since we use the decimal point in the previous thing, I am converting this to a decimal which is having 4 decimals. So 0.3333 with the negative sign. In the previous term, no, we got positive, but here we have a negative value. Minus 0.3333. Okay, come to the formula. What is the formula? Del yn, del squared yn, del cube yn we have. No, I will explain what is that in the difference table. This is my yn. Okay, and this is my del yn, and this is my del squared yn, and this is my del cube yn. So encircle all these values. So when we apply Newton's forward, encircle all these values from y to the higher order difference. Encircle this. This we are going to use when we use Newton's forward. When we apply Newton's backward, encircle this. These values only we are going to use when we apply Newton's backward. Is it clear? This is the formula yn plus v by 1 factorial del yn plus v into v plus 1. There in forward we have taken the subtraction. Here we have to add v plus 1 by 2 factorial del squared yn. Then v plus 1 v plus 2 by 3 factorial del cube yn. Now we have to apply the terms. What is yn? 0.4848. 0.4848 plus what we got as v? Minus 0.3333 by 1 factorial. What is my del? This one. 0.0464. 0.0464. The next one is, this is my v, no? Put a bracket. Minus 0.3333 into v plus 1. Minus 0.3333 plus 1 by 2 factorial into del squared. What is my del squared? Minus 0.0013. Minus 0.0013. Come to the last term. What is that? V. Minus 0.3333. V plus 1. Minus 0.3333 plus 1. V plus 2. Minus 0.3333 plus 2 by 3 factorial into the last term. What it is? It is minus 0.0003. Minus 0.0003. We have to simplify and write the answer. I'll do simple calculation. When you do this one, no. Minus 0.3333 plus 1. What it is? Plus 0. This is plus 0.6667. And when we take minus 0.3333 plus 2. What it is? This is 1.6667. This is 0.6667. 3 factorial already we know it is 6. This is 2 and this is 1. We have to simplify and get the answer. Here the answer what we got is y of 28 is approximately equal to 0.4695. Is it clear how we are applying Newton's forward and backward? I repeat, Newton's forward and backward is applicable only the x values are of equal length. If it is of unequal length, already I have explained that in Lagrange interpolation formula. Lagrange interpolation formula is the formula which we have to apply for unequal interval. If it is equal means either forward or backward can be applied depending upon the x value. Here x value is 21 which is close to the beginning set of values. Fix the mid value. If it is left to the mid value, Newton's forward is applied. If it is right to the mid value, Newton's backward is applicable. If it is exactly the center value, either forward or backward is applicable. If it is forward means we have to calculate V and we have to use the beginning set of values. If it is backward means we have to calculate V and we have to use the end set of values. Is it clear? Thank you.